Hi everyone. So in this video, I would like to explain more examples of QQ-plot. And in the last video that we discussed how QQ-plot looks like when we generate 300 random numbers from standard normal distribution. So Y is the normal, R normal is 300. So this is standard normal random numbers from normal 0, 1. Then when we generate QQ-plot, almost it makes the pattern of Y is equal to X. So this is sample quantile, and the x-axis is theoretical quantile. So it corresponds almost exactly. So most points are Y is equal to X. It's natural that the sum points on the left-hand side and right-hand side has a slight discrepancy from Y is equal to X. So next example. So what happens if mean and the standard deviation has been changed? So think about 300 random numbers which follows a normal distribution but with population 10 and the standard deviation 5. Then basically all observations are shifted upward by 10. I mean, all observation gets 10 larger. So sample quantile is on y-axis, so 10 larger. And also standard deviation is 5. So that means the variability of the value is 5 times more than standard normal. So that makes the slope of the trend line equal to 5. Okay, so everything becomes 5 times wider in terms of the y coordinate. So we expect that all points are on roughly on the straight line y is equal to 5x plus 10. Okay, so we run this code, then generate QQ norm, then it looks like this. It looks almost the same as the last example, but just to see the scale for sample quantile. Actually, the center is 10, and one increment, I mean, this sign and this sign is 10 and 15, so the increment is 5. So actually, it's 5 times. The slope of this trend line is 5 times larger. So this trend line is y is equal to 5x plus 10. So still, even if it's not distributed standard normal, we can check the normality. And if all points are almost on the same line, same straight line, then it's distributed normal. Okay, so think about more distributions. So what happens if random numbers follow a more heavy-tailed distribution? For example, the t distribution with df3, and how QQ-plot looks like, normal QQ-plot looks like. And since originally observations are generated from t distribution, so it doesn't satisfy the assumption. So it doesn't come from normal distribution. So it's not points, the QQ-plot are not on a straight line. So we will see what happens. Okay, so we define y as the random number generated from t distribution, RT function, and df3. Remember that small degrees of freedom, we have more variability. I mean, the heavier tail, so more extreme values. Maybe we can just see first 20 observations, then. Okay, so most observations are around 0, but you can see more extreme values compared to standard normal distribution, negative 4.3 or positive 3.26. So these observations are rarely observed from normal distribution, but actually most observations are around 0. 0.02, 0.42. So except for tail part, it's pretty similar. QQ-plot looks like this. And okay, so most observations at the center, maybe from negative 1 point, maybe maybe negative 1 to positive 1, almost on a straight line. Here scale is 0, 5, 10, so almost probably on the straight line y is equal to x or something similar. But these observations are clearly different largest observation is much larger, the 17, maybe 16 or 17. Second one also 7. So if we think about this trend line is around here, straight line is around here. So these observations are clearly larger, and even these observations may be from 1.5 to 2.5 in X value. So these observations are clearly off the trend line. And the other part is similar. So these observations are much lower than this trend line. So this happens because this sample, random numbers, have extreme values. So the y-axis is actual observed numbers, observed values. So these observations are really large. These observations are really small. So that's why it doesn't satisfy the condition. The pattern does not follow a straight line. So heavy-tailed distribution, we have this kind of, a kind of inverse S-shaped, or in terms of polynomial, maybe the pattern is similar to y is equal to x cubed or something. Okay, so next example, we think about uniform distribution. So uniform distribution is, okay, so is so random observations between interval AB. So AB is given numbers. Suppose A is 0 and B is 1. So just the random numbers between 0 and 1 and uniformly distributed. So if we make a histogram of those random numbers, then that is just square shaped. From 0 to 1, we have just flat histogram, and after 1, I mean above 1 and below 0, we don't have any observations. So that is typical, the light-tailed distribution. No extreme values. All observations are between 0 and 1. So the opposite thing happens. Okay, we can try. So this time, maybe y2. Uniform random variable, so R uniform and 300. Then we have to specify the smallest possible value and largest possible value. Actually, upper bound and lower bound. So actually, the random number never is equal to 0 or 1. But okay, so random numbers are generated between these two numbers. So all numbers are y2. So all numbers are between 0 and 1. And QQ plot for normality, normal QQ plot of y2 is here. Okay, so this is a kind of S-shaped, or the shape is similar to maybe the y is the cubic root of x or something. Okay, so around the center, x is equal to 0. It looks similar to a straight line, but okay, if trend line is around here, these observations are clearly below this trend line because all observations are less than 1. So we cannot go further. It cannot exceed 1. So this largest observation, maybe 0.99, second one 0.98 or something like that. And the other end that we have the same. So if we see this pattern, that we can see distribution of these observations have light tail. So these are the examples of QQ plot, and now that you can see the you can tell from QQ plot what happens for residuals or in general any observations.